All right, let's do this. Probably couldn't have picked a worse possible time to start the stream. It is 3:30 on February 5th, 2017. So it's basically kickoff time for the Super Bowl. So probably no one is watching on Twitch, and I'm late for the party I'm supposed to be at, but gotta get today's stream in, and I'm not doing it after the Super Bowl party. So we're doing it now because I'm leaving late. So yeah, that's that. Coding first for now, at least for 2017. Diving into it. We're finishing off Git section 4, basic Git workflow, 2, how to get backtrack in Git branching, and now section 4, Git teamwork. Let's do this. This should be a short section. Fingers crossed. Okay. What do we have? So far, we've learned how to work on Git as a single user. Git offers a suite of collaboration tools to make working with others on a project easier. Imagine that you're a science teacher developing some quizzes with Sally, another teacher in the school. You're using Git to manage the project. In order to collaborate, you and Sally need a complete replica of the project on your own computers, a way to keep track of and review each other's work. Third, access to a definitive project version. You can accomplish this all by using remotes. A remote is a shared Git repository that allows multiple collaborators to work on the same Git project from different locations. Collaborators work on the project independently and merge changes together when they are ready to do so. Click Next to start working with your first remote. Good. Section 2 of 8. Let's do this. Okay. Day 36, off to a blistering start. Sally has created the remote repository, Science Quizzes, in the directory Curriculum, with which teachers on the school's shared network have access to. In order to get your own replica of Science Quizzes, you'll need to clone it with git clone remote location clone name. In this command, remote location tells Git where to go to find the remote. This could be a web address or a file path such as users, teachers, documents, some remote. Clone name is the name you give to the directory in which the Git will clone the repository. Instructions. 1. The Git remote Sally started is called Science Quizzes. Enter the command to clone this remote. Name your clone My Quizzes. Notice the output. Cloning into My Quizzes, ... Git informs us that it's copying everything from Science Quizzes into My Quizzes directory. My Quizzes is your local copy of the Science Quizzes Git project. If you commit changes to the project here, Sally will not know about them. Alright, so we're going to do... Are we cloning already? The Git remote Sally started is called Science Quizzes. Enter the command to clone this remote and name your clone. So the clone will be My Quizzes, and Science Quizzes will be the remote location. So let's do this. Let's do git clone Science Quizzes, My clone? No, My Quizzes. Okay, there's that. Enter. Cloning into my quizzes, just as it said down here. Nice. Done. Very cool. Section 3. Alright, well that all loads up, don't mind me. Text stuff. Okay. Let's see. Alright, top section 3. Oh, close chat. Good. Onwards. Nice work. We have a clone of Sally's remote on our computer. One thing that Git does behind the scenes when you clone science quizzes is give the remote address the name origin, so you can refer to it more conveniently. In this case, Sally's remote is origin. You can see a list of Git project remotes with the command git remote-v. Using the file navigator, examine the contents of the cloned Git project. There are a few quiz files here. Don't mind, I'm reading text and instructions, and it's just not working well because the human mind doesn't function that way. At least mine doesn't. There are a few quiz files here, which we will begin working with during this lesson. Open a file of your choice in the code editor. Alright, step 1. Code editor, opening file. Open the file navigator. Examine the contents of the clone Git project. There are a few quiz files here we'll be working on during this lesson. I'm going to open stuff within my quizzes. Chemistry or physics. Ooh, let's do... Oh, we'll take a look. Oh, nothing's in there. Aha, but there is stuff in the physics. We're going to go with physics since there's stuff, there's info. Good, onwards. Run. Cool. First box down. This is good. 2. Change directories into the my quizzes directory. Enter this command on the terminal cd my quizzes. To learn more about cd, take a look at our command line course. cd my quizzes. This is change directory, if I believe. Green checkbox. 3. Enter git remote-v. To list the remotes, notice the output: origin, home user, CC, workspace, curriculum, science quizzes, fetch, origin, home, user, workspace, curriculum, science quizzes, push. The git lists the name of the remote origin as well as its location. Git automatically names this remote origin because it refers to the remote repository of origin. However, it is possible to safely change its name. The remote is listed twice, once for fetch and once for push. We'll learn more about this later in the lesson. So I'm just entering the git remote now. Git remote-v. Good. Origin, fetch, push. Lovely. Green checkboxes. Next, 4 of 8. After you cloned science quizzes, you had to run off to teach a class. Now that you're back at your computer, there's a problem. What if, while you were teaching, Sally changed the science quizzes Git project name in some way? Typical Sally. Can you believe her? If so, your clone will no longer be up to date. An easy way to see if changes have been made to the remote and bring the changes down to your local copy is with git fetch. This command will not merge changes from the remote into your local repository. It brings those onto what's called a remote branch. Learn more about how this works below. enter this command, cd my quizzes, to go into the my quizzes directory. Okay, we'll do it again. cd my quizzes. Enter. Green checkbox. 2. Fetch any new changes Sally may have made to the remote. Git fetch. Pretty straightforward. Git fetch. Remote. Counting objects, 6, done. Remote. Compressing objects, 100%, 5 of 5, done. Remote, total 5, delta 1, reuse 0, delta 0. Unpacking objects, 100%, 5 of 5, done. From home, user, workspace, curriculum, science quizzes. Asterisk, new branch, master, origin to master. Okay, well, origin / master. So that's that for page 4, section 5. And before I read that, more text messages to address. You both comment? Okay. I am as well. Okay. Good. Onwards. Back to chat. Section 5. Alright, learning. We be learning. Even though Sally's new commits have been fetched to your local copy of the Git project, these commits are on the origin master branch. Your local master branch has not been updated yet, so you can't view or make changes to any of the work she has added. In lesson 3, Git branching, we learned how to merge branches. Now we can use the git merge command to integrate origin master into your local master branch. The command git merge origin / master will accomplish this for us. Instructions. Enter the command cd my quizzes to go into the my quizzes directory. Cd my, you know what? Can I hit up? Oh, no commands saved a fresh terminal. Oh, and I'm thinking of command line? Yeah, I'm thinking of command line, but this is a command line command, right? Lots of command squared. Command cube? That was a lot of command in one little moment. My quizzes. Enter. We're in my quizzes. You are on your local master branch. In your commit history, the commit message of the head commit is add first question to physics. Spaces, handful of spaces, quiz. From the terminal, merge with origin / master where Sally's most recent commits are. Notice the output. Updating A2, B, A0, blah, blah, ... B, C, blah, blah, A1, A. Lovely. Fast forward, biology.txt, 2, ±, 1 file changed, 1 insertion, 1 deletion. Cool. It has performed a fast forward merge, bringing your local master branch up to speed with Sally's most recent commit on the remote. Okay. From the top, though, because that's just one giant wall of new stuff. What now? You're on your local master branch. In your commit history, the commit message of the head is blah. From the terminal, merge origin with master. So we're gonna take this. I'll type it. Git merge origin / master. Enter. Updating. What's that little cat? Yeah, super sleepy. Hey, it's Topher. Okay, says you're live, but the channel won't load. Odd. Okay. Strange. Almost done though. Almost done though. Section 5. of 8. So the VOD should be available soon. Okay, let's do this. Onwards. Where are we? So we did section 2. We merged, right? Git merge origin master. Updating to stuff, do stuff 3a. And friends, fast forward, biology, 1 file change, 4 insertions, create mode, 100644, biology, and other stuff. 3. Print commit history. In the output, notice the head commit has changed. The commit message now reads, add heading and comment to biology quiz. Oh. Print the commit history? As in git log? Or commit it? I'm gonna do git log. My spidey senses are telling me git log. Oh my god, okay. That makes sense. That's fine, because that's what it is. That shouldn't have been a surprise, but, you know, kind of the blind leading the blind, or really just one blind person wandering aimlessly. But we made it. 6 of 8. Now that you've merged origin/master into your local master branch, you're ready to contribute some work of your own. The the workflow for Git collaborations typically follows this order: 1. Fetch and merge changes from the remote. 2. Create a branch to work on a new project feature. 3. Develop the feature on your branch and commit your work. 4. Fetch and merge from the remote again, in case new commits were made while you were working. 5. Push your branch up to the remote for review. Steps 1 and 4 are a safeguard against merge conflicts, which occur when 2 branches contain file changes that cannot be merged with the git merge command. Step 5 involves git push, a command that you will learn in the next exercise. Okay. Awesome. Channel feed. Well, it seems to be possibly loading. We're testing. We're checking. Alright, friends. Come on, commercial finish. Does my channel load? And we're waiting. Yeah, still not loading. Not loading for me either. Range. Death. Alright, well. We'll continue onwards. Okay. What now? What? 5 things. Fetch and merge, create a branch to work on, develop the feature on your branch, commit your work, fetch and merge the remote again, in case other changes had occurred, and then push your branch up to the remote for review. Steps 1 and 4 are safeguards, and good. Onwards. Enter this command, cd my quizzes, to change directories. cd my hyphen quizzes. Cool. Okay. 2. Enter the git command git branch name. To create a branch to develop questions for the biology quiz, name the branch bio questions. We're going to go ahead and copy that guy. Note, be careful to spell the name Bio questions exactly as it appears. Yeah, with a hyphen. Good. Exactly why we copied it. Get branch bio questions. Crap, do I need to have the carrots? Death. I'm gonna hit enter. Let's see what happens. Gave me a green checkbox without the carrots. Good enough for me. Switch to your new branch with the command get checkout branch names, replacing branch name with the name of the new branch. Get checkout bio questions. Switch to branch bio questions. Cool. Section 4. And on your branch, open biology.txt in the code editor, add a biology question to the file, and some sample answers. For example, what is an animal that hunts and eats other animals called? Predator. I was looking for carnivore, but I guess, yeah, predator, because not all predators are carnivores, but that's just what comes to mind first. So D, good, right? Hopefully. What are we doing? Open branch. No, open biology text in the code editor. We're opening stuff. That was under biology. Add your multiple choice question here. Lovely. Copy. D, paste. Run. Question added. Section 5. Add biology.txt to the staging area. Okay, so, oh, damn. I think that's get add, right? Get add biology.txt. Biology.txt. Enter. Green checkbox. Commit the work to the repository with a commit message. Get commit -m quotes. Predator? No. Bio question. Sure. Bio question. Fire away. Bio question. File changed. Green checkbox. 7 of 8. Now it's time to share our work with Sally. The command get push original your branch name will push your branch up to the remote origin. From there, Sally can review your branch and merge your work into the master branch, making it part of the definitive project version. You hear screaming, it's 'cause of the football game. From others in the other room, not to worry. No one's being harmed. Except for the team that's losing. Good. Rough assumption, though. I haven't seen any of the game yet. So we'll find out. I am almost out of here. Enter this command, cd my quizzes, to change directories to the my quizzes directories. You got it. Cd my quizzes. Change directories. Push your branch up to the remote. In the output, notice the line to home, user, workspace, curriculum, science quizzes, new branch, bio questions. Git informs us that the branch bio questions was pushed up to the remote. Sally can now review your new work and can merge it into the remote's master branch. Good, good. Something, push your branch up to the remote. I don't recall that command. Is it push your branch up to the remote in the output, notice the line. I am totally drawing a blank. What do they have under get? Help one. No. I could check my old yesterday's stuff. Oh, there we go. Pushing. Totally drawing a blank. Totally on edge. Alright, crisis averted. Failure is not imminent. Well, at least not right now. I mean, I suppose in the end everything decays, but not related to Git. Git. That's fit, you son of a... Git push origin my branch name. What is my branch name? Is it master? Or is it the my quizzes? It's my quizzes. My quizzes. Enter error. You son of a git push origin bio questions. Bio questions. That's what it was. Delta compression using up to 3 threads. Writing objects 100%, 3 of 3, 363 bits. Total 3 delta 1 reuse, 2 user workspace curriculum science quizzes, new branch bio questions. And that's the same bit here with the new branch. Lovely. Way cool. Section 8 of 8. Congratulations. Code achievement. Congratulations on completing the Learn Git. You learned a new skill and should be proud. Want to take a look at your profile? Absolutely. After we read this last little bit, congratulations, you now know enough to start collaborating on Git projects. Let's review. Remote is a Git repository that lives outside your Git project folder. Remotes can live on the web, on a shared network, or even in a separate folder on your local computer. The Git collaborative workflow are steps that enable smooth project development when multiple collaborators are working on the same Git project. We also learn the following commands. Git clone creates a local copy of a remote. Git remote-v lists the Git project's remotes. Git fetch fetches all the work from the remote into the local copy. Git merge origin/master merges origin/master into your local branch. Git push origin branch name pushes a local branch onto the origin remote. Git projects are usually managed on GitHub, a website that hosts Git projects for millions of users. With GitHub, you can access your projects from anywhere in the world by using the basic workflow you learned here. Click next to complete the course. Up next, what do we have? Success. Let's shimmy out of this. Let's take a look in general. 364 points. View my profile. Very nice. Learn Git down. And back to learn. We get to go back to deploy a website. So we will be tackling that tomorrow and onwards. Now that we finish the command line in Git, the 2 things needed for the deploy website course, at least recommended for the Codecademy deploy website course that they have set up. So yeah, way cool. That's it for day 36. Job well done. Done by 4. We've only missed the first 30 minutes. Still 30 minutes late to said Super Bowl party, but better late than never. We are closing out. Still in the stream. Still at